Hi, my name is Atwik. Now we are going to see about the experiment number comparative experiment, which is a predictive parsing, which is the seventh experiment. In that, I'm importing my Java files. I created the packages in that, and protecting the char and the int. Defining the array stack, which of the size 20 and the new char, and the top I'm declaring as -1. And for the push, I'm declaring the top plus one is equal to size, and I'm creating a pop, and I'm displaying the values, and I'm inputting the values for the creation of transaction table and the and giving the inputs. For that, I'm defining the buffer reader, and which is a new buffer reader, and inputting. I'm giving the output statement to for entering the number of terminals. For that, I'm getting alpha set an integer dot parsing dot bit, which will be reading the number of terminals in that. I'm creating another output, which is the enter the number of non-terminals. For that, I'm getting state set, which will be taking the number of inputting the number of terminals, and the printing the required number of terminals in that. For that, I'm creating another output statement, which is that enter the starting non-terminal in the grammar, and enter all the terminals simultaneously. For that, I'm creating another input file for the alphabet is called new array list, and entering all the non-terminals. For that, I'm getting alpha is got to new array list, and alpha dot add, and the system for the alpha, for the epsilon, we are using the at the rate, and entering all the row entities by line, and the transaction will be taking. For that, I'm creating the for loop statement, for loop. For that, s is equal to 0 as then state set, which I define for the non-terminals. For the under terminals, I'm defining for the alpha set. Then inputting into then input for the parser. Then the stack will be taking out, and the required pop and push operation will be taking place according to the given input to the transaction table, which will be done, and the parsing will be completed successfully, and it will ask for continuing. For that, I'm creating the scanner. We'll see the output now. Here is the output. For that, it asks for entering the enter the number of enter the number of terminals. Here are the terminals we are entering. Wait. I'm entering as 1 2 1 2 3 4 5 6. So it's 6. Enter the number of non-terminals. I'm entering the non-terminals as 1 2 3 4 5. Enter the starting non-terminal, which is E, and enter all the terminals. Go for I have done. I enter the non. In place of non-terminal, I enter the terminal. For that, I will again run the program. I'm entering the number 5. Enter the starting non-terminal, and enter the odd terminal. D, press star, and dollar. Enter the all the non-terminals. I'm entering E R T Y F. It asks to enter the row entities. We should enter the E arrow T R. Nothing is there for the press, so leave the empty, and again T R, and again empty, and entering another for E dash. E dash I am taking as R for R plus T R space excuse me, R epsilon, again R epsilon. I'm entering for T. T is F Y space T dash F Y space this, but Y equal to epsilon, Y tends to star F5 space Y tends to epsilon, again Y tends to epsilon. Now we should enter for F. F tends to D space F tends to E. It asks to enter the input. I am entering the input as D, press D star D dollar hash. Here is the transaction. Here dollar and dollar are the remaining, so the event parser is successfully running in the program. This is about the predictive parsing. Thank you.